Hey class, today we're working on lesson 11, which is conditionals. All right, so let's get started with this. Um, so this class starts by using Booleans. Booleans are a true or false statement. So it's something that has to be either true or false. It can only be true or false. There's no gray area there. Boole was a mathematician from, I think, the 1700s or something like that, or 1800s, who came up with this idea of having true or false statements. So he is what that's named after, but they're called Boolean statements, or true or false. Okay, so they only have true or false, which is really significant when we talk about coding, because as you know, we already discussed that computers answer yes or no questions. It's a matter of ones and zeros, ons and offs. So Boolean statements are very important when we start talking about coding. The Boolean expression down here in programming is an expression that evaluates to either true or false. Okay, and today we're also going to be introduced to if statements. They're commonly referred to as conditional statements. So you may hear me refer to them as either one of those, but that's what we're going to be doing today. So let's continue here. All right. As this is loading up here, Bubble 2 is actually a prediction level. I'm going to do this with you together and show you how this all works. So decision making on computers are based on statements called Boolean expressions. Boolean expression is any expression that can only evaluate to either true or false. We just talked about that. So this can be particularly useful when used to compare the properties of two different sprites. For example, you can figure out which one is larger or placed up higher. You can figure out which one crosses a finish line first if you're having a race. So we'll use simple Boolean expressions to compare sprite properties. All right, we're going to read the code below here. There are some new symbols in which you haven't been introduced to. Take a guess at what they mean and try to answer the following question. Which result will be printed in the console by this program? All right, so here's console log down here. And what that's going to do is that's going to, down here in this debug console, it's going to give you statements, true, false. Sometimes it'll give you numbers down here depending on what you're asking it to do. In this case, we have Boolean statements, which are true or false statements down here for each of these. And we're given a variable, sprite1, create sprite at x 100, y 200. Remember, the first number is the x coordinate, the second is the y coordinate. So it's going to create sprite 1 at x 100, y 200. If we show our grid over here, we can see that x goes over here. Each of those squares is 50, so x is 100, y is 200 down, so it's going to draw it right at that intersection right there. And then sprite 2 is being created at 300, 200, which is going to be right over here. 300 over, down 200. So that's where sprite 2 is going to get drawn. And we're going to predict what each of these commands is going to print. So in the console log, sprite1.y is equal to sprite2.y. So here's sprite 1. Here's sprite 1's y, which is 200. Here's sprite 2. Sprite 2's y is 200. So that would be 200 is equal to 200. So that should be true, right? True. Okay, so the second one is going to be sprite1.x is greater than sprite2.x. Sprite1 here dot x is 100. Sprite2.x is 300. So is 100 greater than 300? No, so the second one should be false. So we should have true, false, and this third one, sprite1.x is less than sprite2.y. Sprite1.x is 100, sprite2.y is 200, so 100 is less than 200, so that is true. So we should be looking up here for true, false, true, True, false, true. There, bubble A. We're going to run it and see what we get. Down here in our debug console, we see true, false, and true again. So that's right. And we're going to finish that and move on. Let's watch our video.
My name is Felicia Williams, and I work at Facebook in augmented reality and virtual reality. Augmented reality is going to really change the way that we think about using computers, and it's a really fun place to be right now. Whether you're making an animation, an app, or a game, it's often necessary for your computer program to test a condition to see if it's true or false. To do this, we use a Boolean expression, an expression that can only evaluate to either true or false. This is similar to asking the computer a yes or no question. Let's look at 3 types of expression that we can make with comparison operators. 2 equal signs compares the values in each box and asks, are these 2 values equal to one another? The greater than sign compares 2 values and asks if the value on the left is greater than the value on the right. And finally, the less than sign compares the 2 values and asks if the value on the left is less than the value on the right. For each comparison, we will get either a true or false answer. For example, when playing a game, you may get a bonus when you reach a specific score, say 100. To know when to give the bonus, the computer will use a Boolean expression that asks, is the value stored in the variable score equal to 100? If the expression evaluates to true, then you will get a bonus. If it evaluates to false, nothing happens. We can use another comparison operator to make our game even more accurate. In this example, the bonus is only given if the player's score is exactly 100. But if the player passes 100, they should still get the bonus, right? To do this, we'll use the Boolean expression that asks, is the user score greater than 99? If this is true, then the player gets a bonus. By using Boolean expressions to ask true, false questions, you can make your animations, apps, and games even more dynamic and interactive for your users.
All right, so the simplest Boolean expressions are questions the computer can answer with true or false. Another way to say that is Boolean expressions evaluate to true or false. Do this. Can you modify the values of the sprite property so that each of the Boolean expressions evaluates to true? So we're going to try to make each of the Boolean statements down here be true. Okay, for each Boolean expression, identify the sprite's property being compared. Change the code in the first 11 lines only. So we're only changing code in the first 11 lines to make this print true for every one of these Boolean statements. So let's go up here and try to give us as much space as possible so we can see as much of this code as possible at one time. Okay, so here we have our 2 sprites being created. 100, 200, 300, 200, so it's the same spot. Sprite 1 is going to be an apple. Sprite 1's rotation is 30. Sprite 1's scale is 1.5. Sprite 2 is going to be a carrot. Sprite 2's rotation is 60. Sprite 2 scale is 0.5. Okay, so we need to change the code up top here to make Sprite 2's X be equal to Sprite 2's Y. So Sprite 2's X equal to Sprite 2's Y. Let's make that 200. 200. So here Sprite 2 It's x is 200, it's y is 200. So that makes the first one be true now. All right. Comparison 2, sprite 2 dot rotation is less than 40. Here we have sprite 2 dot rotation is 60. So let's make sprite 2's rotation be 20. That will be less than 40. So that one is true now as well. And then we go down here to comparison 3. Sprite 1 dot scale is equal to sprite 2 dot scale. So we have sprite 1 dot scale is 1.5, sprite 2 dot scale is 0.5. Let's change them both to 0.5. You'll notice here, by the way, this is just a little sidebar. You see that when we don't put the 0 in front of the decimal point, you get this warning triangle. It says a leading decimal point can be confused with a dot. So whenever we're doing code, come on now, we're going to do .5. We'll put the 0 in before the decimal point for that. So now our sprite 1 scale is equal to sprite 2 scale. That's here. And then we have comparison 4, sprite 1 dot x is greater than 150. Sprite 1 dot x is greater. Sprite 1 dot x needs to be greater than, what number was that again? 150. Okay, so let's make sprite 1 dot x be equal to 300. That will make it bigger than 150. And then comparison 5 here, sprite 2 dot y is less than 200. Uh-oh. Okay. So sprite 2 dot y is this number here, has to be less than 200. We have it at 200 right now. So we need to change this and make it less than that. So let's go 150. But if you'll remember here, we had sprite 2 dot x had to be equal to sprite 2 dot y. So we're going to change both of these right now. 150, 150. I think that's about right. So let's go ahead and run this now. And we'll see our comparison down here in our debug console. You have comparison 1 is true, comparison 2 is true, 3 is true, 4 is true, and 5 is true. So those are all good. So we completed what we needed to. You can do this a whole bunch of different ways. You may have your sprites be drawn on top of one another. The image doesn't matter for this particular bubble. The only thing that matters is that you get trues for all of these. And there's a million different ways you could fix these numbers up here as you go through them. But again, you need to make your changes in the first 11 lines of the code. So we're changing up here. We're not changing these Boolean statements down here. See where it says, don't edit the following? I'm serious. I'm serious. Don't edit those. Okay. Moving on. And now we're at bubble 5, which is matching comparison operators. Okay, I'm going to let you figure this one out on your own. You're going to do this by dragging these over to the appropriate places. Okay, so I'm going to let you figure those ones out. That's a fun challenge for you. And here we go with bubble 6. Booleans. In the past few levels, we've been comparing values of sprites to find out whether something is true or false. Let's start putting that into context of an animation. So the program here draws a race car and a finish line. Let's go ahead and run this. So here's your finish line, here's your race car. It's a pretty slow race car, but it's a race car nonetheless. Okay, we're going to figure out when the car crosses the finish line. The sprites have all been set up for you. Okay, so add a console log statement. So we're going to add a console log statement down here inside of the draw loop. Okay, and if you have a question about where you're going to do that, then you can click on show me where, and it will show you exactly where to do that. See, put the console log statement right here. So here's a console log statement. We're going to drag it over and drop it. Okay, so we put the console log statement inside the draw loop, add a Boolean expression inside of the console log that asks is the X position of the race car less than the X position of the finish line. So we're going to come over here to our math statements. We're going to scroll down, find the less than sign. We're going to put the less than in here. Okay, so is the race car's X what was her name of her? Okay, it's named race car. Race car.x, is that less than finish line in camel case? Finish line.x. Right? Reset and run. And we see down here our debug console is going false, 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 false. And it's going to keep going false until the car crosses that line. Wow, we need to speed our race car up some. We should see this changing to true here at some point. There it goes. So now it's true. Okay. So we finished that. Why does it change at that point? Well, because the race car's X, race car.x, was less than finish line.x. And that's what we were looking for. All right, bubble 7. More practice with Booleans. Let's use one more Boolean expression to check a condition of a sprite. You can use a console log command to check whether its scale is 2 yet. So we're going to add a console log statement inside. Again, we add the console logs inside of the draw loop here. Okay. We're going to put a Boolean expression inside the console log that checks whether the fruit scale is greater than 2. So we need a math statement, and we need the greater than sign. We're going to put that in our console log, and we want to know if fruit.scale, right? There's our sprite.scale, and that is fruit.scale if it's greater than 2. That's all we're asking, okay? And so we will run this and see. It's false, 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 false. Down here, we're going to keep getting falses until the sprite scale gets bigger than 2. And it's increasing by 1/100th here. Again, 30 times every second this thing is drawing. So you're going to start to see trues come up as soon as that sprite scale, there it goes, gets to 2. Now it's above 2, and your console log down here has changed to true. All right. That's pretty easy. Moving on. Okay, Booleans and comparison operators. So conditionals, Booleans, expressions, and statements. We're hearing a lot of new words today, and that's okay because we're going to get through these. All right. So Boolean values, Boolean expressions, all kind of mean the same thing. If you ever hear Boolean, you just need to remember true and false. Okay, that's the key thing here. So a Boolean expression is a statement that evaluates to either true or false. Conditionals or conditional statements are oftentimes called if statements. So these are things that if something is true, then something else will happen. Okay, and so we're going to take a look at, here's the Historical notes on Booleans, named after mathematician George Boole, invented a corner of mathematics that is now named after him called Boolean algebra. All right. Anyways, comparison operators here. You have the equal, equal. The two equal signs means is equal to. Remember, one equal sign in coding means gets, is usually translated as gets. So sprite.x gets 200. We'll draw the x value at 200. So we don't really say equals in coding, but it does mean the same exact thing. Okay, so two equal signs is equal to. An exclamation point and an equal sign means not equal to. Okay. So the assignment operator is a single equal sign, then is equal to is the two equal signs, and you can even go three equal signs, which means is really, really equal to, and it won't stretch or try to get make anything that's close to being equal. Equal, the two equal signs will give you that. The three equal signs, it needs to be absolutely exact. Here's our greater than, less than. Same thing in math. Greater than or equal to, less than or equal to. All of those things are they mean exactly what they do in your math classes. Okay. So below are a bunch of examples of how you might see comparisons in code. Review them. So I'm not going to read everything down there for you, but you should take a look at them. Try to figure out these things. Remember, the exclamation point means not. All right. We'll continue on. Level 9, we have a new video.
The world around us is constantly changing, and we do our best to adapt to different conditions. If it's sunny outside, wearing sunglasses is a good choice, but if it's raining, you'll need to put on a raincoat. Just like humans, computer programs also change depending on different conditions. To make our programs responsive, we use conditional statements. Conditional statements are commands that run a specific block of code only if something is true. The simplest conditional is an if statement. An if statement uses a Boolean expression to ask a true or false question, and then runs the code inside if the Boolean evaluates to true, like this. Let's look at an example of conditionals in action. First, we'll create a sprite. Then we'll use the draw function to draw the background. And move the sprite across the screen using the counter pattern. We'll add a conditional if statement inside the draw function. Inside the conditional, we'll put a Boolean expression that asks, is the sprite's x position greater than 200? In this case, let's change the look of the sprite if it moves past the middle of the screen. Finally, we'll draw our sprite and see what happens. Computers only do exactly what we tell them to do, but with conditionals, we can have our programs adapt to changes and respond to user input.
Okay, so moving on to bubble 10 here. It ever loads for us. Okay, so an if statement here. Boolean expressions are used earlier, allow us to ask questions, but in order to respond to those questions, we need to use an if statement. If statements usually go inside your draw loop because we want to check them every time it runs through the draw loop. So remember, if you just check it one time, as that sprite's x coordinate keeps changing as it keeps moving across the screen, you may not get the result you want unless that if statement is actually inside of the draw loop, because it won't run and ask that if question, that Boolean question, every single time unless it's in the unless it's inside of that if statement is inside of the draw loop. Okay, so the race car program we wrote earlier is loaded here for us. Okay, so here's our race car program. You see that it's linked to a previous lesson. And here's our console log that we added in with the race car x less than finish line.x, if you remember that. Okay, so we're going to add an if statement in here, and that's under control. So we add an if statement inside of our draw loop. Okay, wants us to move the Boolean expression from the console log statement to the conditional of the if statement. So let's scroll down a little bit here. So here's our Boolean statement from our console log. Everything there in the orange, that's our Boolean statement. We're going to move that down here to our if statement. And then we can just get rid of the console log completely there. Okay, now inside the if statement, add a statement to draw text on the screen to say winner. All right, so drawing, and we're going to find our text here. We want it to say winner there. Let's draw that at 100, x and y will be down 100 as well. 100, 100. And then, you know what, let's make our text be a little bit maybe bigger here. Go with our text size and make it 50. Let's see how that looks. And we will run our program here. There's our slow race car again. Crosses the finish line and winner pops up there. Okay. If we wanted to speed our race car up, again, here's our code that's making our race car move. That's our counter pattern. Racecar.x equals racecar.x minus 2. If we go minus 4, it's going to be twice as fast. And there it is, moving twice as fast. Still gets across and displays the winner for us. Bubble 11 and conditionals. Changing fruit. Now that we know how to use if statements, you can do more than just check if the apple has reached that scale of 2. You can turn it into a pair once that happens. Okay, so we're going to use conditional in the draw loop to check whether fruit.scale is greater than 2. If it is, we want to change the fruit's animation to a pair. So let's get our code up here. And here's our, again, our console log. Here's our Boolean statement, fruit.scale is greater than 2. All right, so we're going to add an if statement in here. If fruit.scale is greater than 2, and we can get rid of the console log. Now, what do we want to have happen? Well, if you take a look up here, your fruit is set at animation of apple. So we're going to go up here and we're going to change fruit. Has to be spelled exactly the way it was spelled when we created your variable up here. We're going to set its animation at, well, we check and see if we have a pair over here. And we do, and it's called pair. So we're going to come down here and say fruit set animation as pair. And so now when the fruit scale gets greater than 2, it should become a pair. We'll run that and see. So our apple's getting bigger and bigger and bigger. And it changes to the pair. And the challenge, can we also make the fruit stop growing once it turns into a pair? So we're going to do that with the sprite.scale. And we're going to put that inside of this if statement as well here. Because if the fruit scale is greater than 2, then we want the fruit scale to be equal to, and we're going to change it to 2.01. Because it needs to be greater than 2 in order to stop. And that's going to stop it from growing. And let's see what happens. Our apple's getting bigger, changes into a pear, the pear stops growing. It's exactly what we were asked to do. All right, so that is lesson 11. It's moving on here to, I believe bubble 12 is an individual project part. Oh, it's more information, understanding program flow. So you can read that. Here's how the if statements work. Okay, if statements are lines of code you use to change the flow of a program while it's running. You can write code that determines which lines of code should run next. Okay, so if this conditional in here is true, if this Boolean statement, that true or false statement, is true, then here's what happens. Okay, so your condition to be evaluated is a Boolean expression that evaluates the true or false. That's what goes up here in the if statement. Then this is what you want to have happen is if that is true, then this stuff happens. If this is not true, then none of this stuff is ever going to happen. Okay, so you need to be aware of that. All right, that is it for lesson 11. There's some extras here for you to try. I would encourage you to do that because the more practice you get at this, the better you're going to be. But you now should be able to do lesson 11 without any difficulty. And good luck. We will see you later.